All right. Well, welcome to Scientific Biography. It's our first one in a while, and we wanted to start off with someone pretty important. That is Dmitri Mendeleev. Dmitri Mendeleev well, we'll learn about him in a little bit, and his table is very important. What table is that, you may wonder? Well, we're going to find out. Let's move on. Mendeleev's life. So Dmitri was born in 1834 in Russia, and he was born actually out in Siberia. So he lived out in the eastern cold part of Russia. He was the youngest of 17 children, so he had a big family. Only 14 of his brothers and siblings lived to be baptized, which means they didn't live very long, the three that didn't make it, because you get baptized when you're pretty young. His family moved throughout Russia during his life, from Siberia to Moscow and then on to St. Petersburg. And in the 1850s, while he was in school, he contracted tuberculosis and he had to move to Crimea, which is now a hotly contested region, but was once part of the Russian Empire. Mendeleev's career mostly focused on the capillarity of liquids, which is just how liquids move through narrow spaces, often opposing forces like gravity. This is kind of like the study of how blood vessels work. So it's pretty important stuff, pretty big applications for biology and other sciences. He also worked with spectroscopes, which measure the properties of light for the electromagnetic spectrum. So he was one of the first people to really, not the first people, but he's one of the people who was working on this kind of stuff during his career. His dissertation, when he got his PhD, was titled On the Combinations of Water and Alcohol, and it was published in 1865. So he did have a PhD from a Russian university. Now, his biggest thing that he was able to do is create the periodic table of elements. And this is such a big deal because no one had attempted to do this before. Mendeleev created this table, organizing the known elements by their traits, and it was so well organized that it even predicted the existence of elements that we didn't even know existed yet. So we hadn't discovered some of the elements that were on the table, but he had spots there on that table, predicting that they would be there based on the trends that he saw from all the elements that we already did know. This is what the periodic table looks now. As you can see, it's been expanded quite a bit. Now we have 118 elements. Back when he created the table, his first table only had, I think, about 20 elements in that range. So he was working with a lot less, and now obviously we've done a lot more with it. It's much larger, and if you're in a chemistry class, you'll use it all the time. It can teach you a lot of important stuff. Speaking of that important stuff, some of those things could be called periodic trends. These are the things that we see as we look at the periodic table. Here are just a few of them. The first one being that the atomic radius, which means how big an atom is, gets larger as you move left across the table. So as you move left, the radius, the size of an atom increases. Ionization, which is atoms losing electrons, they do that less as you move left across the table. And that's because metals lose electrons well, and metals are on the left. This is supposed to say right. I totally biffed on that one. Right across the table, same thing, right across the table. The non-metals are on the right. So if you move right, they're going to be worse at ionization. On the opposite hand, then, electron affinity, as you move left, it's going to be easier for them to gain electrons because they're really bad at losing them. Instead, they gain them. And then the electron distribution and metallic character can also be gleaned by looking at the periodic table. Thanks again for watching, and please subscribe and ring the bell. The more you guys watch, the more you guys subscribe, the more stuff I'm going to be able to do. So thank you guys so much for watching, and we'll see you later.